In section 2 of chapter 3, we're going to be doing binomial distribution deconstruction, aka reverse area model. It does have another name that you'll probably be more familiar with, but those are what I'm going to be keeping to for at least the time being. Now, this is what we just got done doing. We just got done dealing with two binomials being multiplied together, constructing an area model, and then filling in the exterior. Here's the 2x plus 7. Here's the 5x and the minus 1. And we multiplied them together. To get the top left area of the box, it's going to be 5x times 2x, which is 10x squared. To get the top right box, 5x times 7, because it's 5x tall, 7 wide. That'll give us a positive 35x. To get the bottom left, it is negative 1 tall, it is 2x wide. Multiply them together, you get negative 2x. Bottom right box, it's negative 1 tall, 7 wide. So that leaves us with negative 7. The diagonal boxes are like terms, so they can combine together to get us our final answer of 10x squared plus 33x minus 7. This is our final answer. And that's fine. That's handy, but you've been doing this for a long time. In fact, the next thing we're about to do, you've also done for less of a long time, but still for a fairly long time. We are now going to do the exact same process. We're just going to do it in reverse. I'm going to fill in the area model for you. You need to figure out the original product of two binomials that produced it. Well, if the area model involved multiplication, then this reverse area model is probably going to involve division. So here's how I go about doing this. I'm looking for a number that can divide into 3 and 12 evenly. Well, that's the number 3. This has an x squared, this has an x, which means I know whatever number this is has to have at least a single x. Now I'm going to do the other one. There's a 3 here and a 1 here. They both have a 1 in common, so this could be a 1, but they also both have an x, so it's going to simply be x. This row, I'm looking for a number that is divisible by 12 and 4. That's going to be 4. And I should verify that 3x and 4 give me 12x. They do. Additionally, I like putting a plus inside or next to the 4 just to remind me that it's a positive. And that means the very, very last number has to be a 1. But if I want these two terms to be negative, it would need to be a negative 1. Do not leave your answers like this. If you leave your answer like this, you are not going to get full credit. I know that you know the answer, but you need to write it as a product of those two binomials. 3x minus 1 times x plus 4. For those that do not know, what we are leading into is called factoring. Factoring is the big F word in math. It is the most important concept that you're going to be utilizing regularly in this class. I would go so far as to state, if you do not know how to factor or you feel uncomfortable factoring in this class, this is going to be an extremely rough year and it is going to be very hard for you to pass this class. Factoring is something that is going to show up again and again and again and again. Not just in this class, but also pre-calculus and calculus and beyond. If you need to know one skill inside and out from this class, this is it. We're going to make this more complicated. I am going to show you more techniques involving factoring, but this is critical. Make sure if you are confused, you seek help from either each other or from me. You cannot struggle with factoring. And this is the chapter where we're going to be fully unraveling it.